Ja, vi... Nej, vänta, jag tar om det. Jag bara kör.
Jag klipper bara.
Okej. Sheba-projektet, det är ett projekt som startade för ungefär 3 år sedan. Det sattes ihop ett konsortie som leds av IVL och Jonna Moldanova, och vi är ungefär 10 olika partners. Och syftet med det här projektet var att man ville från EU-nivå så vill man mer kartlägga hur stor är den samlade belastningen av alla möjliga typer av utsläpp från sjöfartssektorn och hur det påverkar just vattenkvalitet och luftkvalitet. För tidigare så finns det rätt många projekt där vi har tittat på till exempel då hur mycket biocider som frisätts från båtbottenfärger och hur mycket som då kommer till vattenmiljön. Vi har andra projekt där vi tittat på till exempel mycket näringsämnen som kommer från gråvatten och svartvatten, men aldrig har man tidigare då försökt göra en mer kumulativ och då samlad bedömning av hur stor är påverkan från hela sjöfartssektorn på Östersjöns miljö.
An important aspect of the work in Sheba is that we use actual ship traffic data. All commercial ships have a so-called AIS transceiver, and this AIS transceiver signals to satellites where the ship are, and that means that we can know using this data we can know where all the ships have been. We have then used emission factors for different pollutants, and we have used computer models to generate simulation of where these pollutants go, how they are dispersed, and we have also estimated the impacts that the pollutants then have on the ecosystems. We have also made different scenarios for the future ship traffic activity, including future regulations of shipping. And from those future scenarios, we have simulated the impact that shipping will have.
In the Sheba project, we have been looking at the effects of shipping emissions on air quality in coastal regions of the Baltic Sea. Ships emit a large amount of pollutants, so nitrogen oxides, for example, sulfur oxides, and also particles, and these particles contain black carbon. And all these pollutants, they are harmful for human health, so they can quite significantly deteriorate air pollution or air quality in coastal regions of the Baltic Sea. So we first calculated the emissions from the ships in the Baltic Sea area, and then we put these emission amounts into chemistry transport models, and these models calculate the transport and also the transformation of the pollutants in the atmosphere. So finally we get information about concentrations of the pollutants in certain areas. And we did not only look at the entire Baltic Sea coast, but we also had specific looks into harbor cities in the area. And so there we also looked at the effects of emissions from ships in ports and not only at ships sailing the Baltic Sea. Well, we first looked at the impact of shipping emissions on today's air quality. And what we found is that, of course, very close to the main shipping lanes, so close to the Danish coast, close to the southern Swedish coast, we have the largest effects on air qualities. And then again, in big cities, in big harbor cities, for example, also in Gothenburg, where you have a big port, ships can contribute something like the same amount to particle concentrations and to NO2 concentrations. So something like 30% in the end comes from shipping. And that's a quite significant amount. And so this is what we found for today's situation. And then we also looked at what might happen in the future. And so we looked at 2040 as our target year for future scenarios. And for 2040, of course, we assumed that ship traffic would still increase, but on the other hand, you have technology measures to reduce the emissions. So there are certain regulations in place in the Baltic Sea, and they will have consequences on the emissions from ships. Well, air pollution is still seen as one of the major threats to human health in Europe. So nitrogen oxide concentrations and also particle concentrations in the atmosphere, they can cause a number of different diseases and can even cause premature deaths. And so shipping contributes to this air pollution in coastal areas and also in major port cities. On the other hand, these pollutants, they are also washed out of the atmosphere, for example, in rain events, or they are deposited on the soil or on the surface on the leaves of trees. And this also has consequences. For example, nitrogen is imported into systems, into ecosystems. So, for example, into lakes or on fields, in soils, and in many areas we have too much nitrogen. And this excess nitrogen might change biodiversity and might change the ecosystem in certain areas.
So in the Sheba project, my responsibility has been the work package dealing with underwater noise. So we've been trying to develop tools how to model the underwater noise from ships. So this is an area which has been usually associated with naval research. So not on the civilian side, but on the military side. So this is our first attempt to find or construct modeling tools so that we can get an idea what is the baseline for the underwater noise in the Baltic Sea. So the next step is the finding out how noise impacts marine life, but we start with the noise emissions first.
Why are noise emissions an issue?
Well, basically the straight answer is that we do not know whether it's an issue, but it may become an issue. So the simplest way of dealing with the impacts is that if there is a problem with communications between different kind of marine mammals or fish, then they may not hear each other anymore. So it can be a disturbance. Another effect is that if there is a very noisy area, then the different species may start to migrate to different areas. So looking for silent spots for spawning areas. And if it's a very loud noise, then it may be that there may be physical consequences. So having this kind of a hearing loss or temporary basis, or whether it's a permanent, it can also be lethal. So it's a very loud noise and very nearby the sound source, then it can kill the subject. But what we found out in Sheba is that finding out the impacts of noise, it's not very straightforward thing to do, because we don't speak fish. So we would need to observe the behavior or response of fish, for example, when we play back the shipping noise back to the fish. So we would try to see that whether there are any panic reactions or other behavioral changes. There are basically a number of things you can do. First one is that you change your behavior. So with noise, it seems to be that faster you go with your vessel, the noisier it gets. So the first immediate thing would be that you slightly slow down your ship. Second thing that you can do, which is a kind of a longer term effect, is that you change your design. So basically you take noise emissions into account when you design a new ship. Currently that is not done because there is no requirement to reduce underwater noise. And so whatever exists on the environmental side concerning noise, those are voluntary guidelines. So you don't have to follow them. You are not absolutely required to do so. You can, but you don't have to.
Det som jag främst har jobbat med, både i Sheba-projektet men även i projekt tidigare, det är att titta på vilken belastning vi har utav olika biocider då från båtbottenfärger. Och en av de största resultaten som jag tycker vi har tagit fram i Sheba-projektet är att vi har jämfört då hur stor är belastningen från båtbottenfärger med avseende då på koppar, som är den huvudsakliga biociden som används i färger, och jämfört det med andra typer av utsläpp, då, landbaserade utsläpp. Och det vi ser att på en årlig nivå så ungefär 25% av all koppar som kommer till Östersjöns miljö kommer faktiskt från fartygsfärger som då är målade på fartyg. Och vi ser även då att miljöövervakning i svenska kustvatten, att här har vi förhöjda halter av koppar som potentiellt kan ge negativa effekter för ekosystemen. Så det här är någonting som man förmodligen måste jobba vidare med och att hitta andra typer av lösningar för att minska då den här miljöpåverkan på Östersjön med avseende på båtbottenfärger.
Regarding the emissions of pollutants that give eutrophication, we can see that the emissions of nitrogen from ships can be over 20,000 tons per year, and that represents approximately 10% of the increase in the natural background concentration of nitrogen. For phosphorus, the ship emissions can give an increase of approximately 5% of the natural background concentrations. So these are still a substantial amount of nutrifying compounds to the Baltic Sea. So the emissions of these nutrients will also increase the area of the sea bottom that has very low oxygen concentrations. And oxygen is essential for all fish and most of the animals down there. Shipping also emits a large number of chemical contaminants. Over 600 different chemicals might actually be emitted from ships to the Baltic Sea. The most problematic chemicals are those compounds that is used in anti-fouling paints. Anti-fouling paints are used to prevent growth of different types of algae and animals on the ship hull. And when we rank the risk of all the chemicals emitted from shipping, copper and zinc from anti-fouling paints actually comes out as the compounds with the highest environmental risk. It is also important to remember that a large number of chemicals emitted from shipping can actually be a problem in itself. When organisms are exposed to several chemicals, there is a so-called mixture effect, or as it's also known, the cocktail effect. So this means that the more chemicals an organism is exposed to, the more hazardous it is. And in some areas in the Baltic Sea, the threshold for this mixture effect from chemicals is exceeded. In other words, the chemicals from shipping represent a risk to the Baltic Sea ecosystem in some areas. It is also important to remember that shipping is regulated, for example by IMO, the International Maritime Organization. And one of the good news is that IMO will actually now prohibit, they will ban the emission of black water to the Baltic Sea in the close future.
The Sheba project has been now running for more than 3 years, and we have been working together, experts from different disciplines, learning from each other and creating together framework for assessment of environmental impacts of shipping. We have calculated emissions from shipping with the most latest methods which are available. We have assessed the impacts using results of latest research. And we have also looked at future development of shipping, how the economic development and the policies which are in the pipeline will impact emissions and environmental impacts of shipping in future. The Sheba project is now soon finished. I really hope that our results will be for benefit of the Baltic Sea region and also for development of shipping industry towards sustainability.